Welcome back to my series of videos working through the SonicPy tutorial. In this video, section 5.6, Variables. Variables. A useful thing to do in your code is to create names for things. SonicPy makes this very easy. You write the name you wish to see, an equal sign, then the thing you want to remember. Sample name equal loop amen. So like this, sample equal loop amen. Here we've remembered the symbol :loop amen in the variable sample name. We can now use sample name everywhere we might have used loop amen. For example, sample name equal loop amen, sample name. Let's try that run. Okay, that worked. There are three main reasons for using variables in SonicPy: communicating meaning, managing repetition, and capturing the results of things. Communicating meaning. When you write code, it's easy to just think you're telling the computer how to do stuff. As long as the computer understands, it's okay, right? However, it's important to remember that it's not just the computer that reads the code. Other people may read it too and try to understand what's going on. Also, you're likely to read your own code in the future and try to understand what's going on. Although it might seem obvious to you now, it might not be so obvious to others, or even your future self. One way to help others understand what your code is doing is to write commands, as we saw in the previous section. Another is to use meaningful variable names. Look at this code. Sleep 1.7533. Now, what on earth is that for? Why does it use the number 1.7533? Where did this number come from? What does it mean? However, look at this code. Loop amen duration equal 1.7533 and sleep loop amen duration. Now it's much clearer what 1.7533 means. It's the duration of the sample loop amen. Of course, you might say, why not simply write sleep sample duration loop amen? Which of course is a very nice way of communicating the intent of the code. Well, why not just do this? Because we wanted to show how the variable works. Managing repetition. Often you see a lot of repetition in your code, and when you want to change things, you have to change it a lot of places. Take a look at this code. We have sample loop amen sleep sample duration of loop amen, then sample loop amen with rate 0.5, sleep sample duration of loop amen rate 0.5, sample loop amen sleep sample duration of loop amen. So you'll notice we've been typing sample duration a lot. I mean, we've been typing loop amen quite a few times. We're doing a lot of things with loop amen. What if we wanted to hear what it sounds like with another loop sample, such as loop Garzul? We'd have to find and replace all loop amens with loop Garzul. That might be fine if you have lots of time, but what if you're performing on stage? Sometimes you don't have the luxury of time, especially if you want to keep people dancing. What if you wrote your code like this? So sample name up at the top, name equal loop amen, and then we go through here and sample name equals sample name. We replace loop amen with sample name wherever it appears. Now this does exactly the same as above. Try it. Alright, let's listen to it. It does exactly the same as the above. But it also gives us the ability to change just one line, sample name loop amen, to sample name equal loop garzul, and we change it in many places through the magic of variables. Let's try that. Loop garzul. It's a little long, but that's okay. Yeah. Alright, the point of all that was sample name variable. Capturing results. Finally, a good motivation for using variables is to capture the result of things. For example, you may wish to do things with the duration of a sample. SD equals sample duration of loop amen. We can now use SD anywhere we need the duration of the loop amen sample. Perhaps more importantly, a variable allows us to capture the result of a call to play or sample. S equal play 50, release 8. Now we have caught and remembered S as a variable, which allows us to control the synth as it is running. So we'll try this, sleep 2. Control S note 62. We'll look into controlling synths in more detail in a later section. Well, yes, a later video also. Alright, we'll listen to this. Okay. The next section is optional. It's a lot more technical and kind of relies on some things we haven't gotten into. I'm still going to present it, but I'm not going to try to get ahead of myself and explain all of the underlying things that are happening. So feel free to maybe skip this for now and come back to it once you've seen more of the videos, or feel free to stick around and try to keep up. Either way is fine. Warning: variables and threads. Whilst variables are great for giving things names and capturing the results of things, it is important to know that they should typically only be used locally within a thread. For example, don't do this. A equal ring 6, 5, 4, 3, 2, 1. Like I said, that's some stuff we haven't seen yet. Live loop sorted do A equal A dot sort sleep 0.5 put S sorted I don't know what that does, but that's okay. And live loop shuffled do A equal A dot shuffle sleep 0.5 and in the above example, we assign a ring of numbers to variable A, and then it is used within two separate live loops. I think live loops are like threads, but they keep looping. In the first live loop, every 0.5 second, we sort the ring to ring 1, 2, 3, 4, 5, 6, and then print it out to the log. If you run the code, you'll see that the printed list is not always sorted. This may surprise you, especially that sometimes the list is printed as sorted and sometimes it is not. This is called non-deterministic behavior and is the result of a rather nasty problem called a race condition. The problem is due to the fact that the second live loop is also manipulating the list, in this case, shuffling it. And by the time the list is printed, sometimes it is just being sorted and sometimes it is just being shuffled. Both loops are racing to do something different to the same variable, and every time round a different loop may win. So let's take a look at this. Let's see, I made some mistake here. A equal a dot sort. And looking at it go, it's pretty much been shuffled every time. Let's run it again and see what behavior we have. And now it's sorted. Oh, that's weird. It's unsorted, sorted, sorted, unsorted, sorted. Let's make this go a little slower. Sleep 1 on each of these. Sorted, no, sorted, not, so not sorted, sorted, not sorted, not, so yes sorted, not sorted, yes sorted. Okay, you get the point. That's over here, by the way. I don't think I can select that, but it's up there. Okay, there are two solutions to this. Firstly, don't use the same variable in multiple live loops or threads. For example, the following code will always print a sorted list as each live loop has its own separate variables. So I'm going to end up doing some copy pasting here because basically all we've changed is move the variable declaration inside of the live loop, and apparently we can use the same variable name, but it's a different variable because it's in a different context. I might prefer this to be B, so it's more clear that it's different, but that's okay. So now we should see that it's always sorted. And also, just to demonstrate the point, we can put the print statement in here and it should always be shuffled. Yep, it's shuffled. However, sometimes we do not want to share things across threads. For example, sometimes we do want to share things across threads. For example, the current key, BPM, synth, etc. In these cases, the solution is to use SonicPi's special thread-safe state system via the functions get and set. This is discussed later in section 10. Okay, that's a wrap for this video. Thanks for watching.